Let's look at this drawing showing all the possible paths you could take from A to B and B to C. Now, if you wanted to calculate all the possible paths you could take from A to C, we would need to look at the number of paths from A to B, which is 4, and B to C, which is 2. And since for each of the paths from A to B, there are 2 possible paths you could take from B to C, this means that to find the total number of paths you could take from A to C, you just need to do 4 multiplied by 2, which is 8 paths. And this is related to the product principle, and the product principle states if there are m different ways of performing an operation, and for each of those operations there are n different ways of performing a second operation that's also independent, then there are m times n different ways of performing the 2 operations in succession. And this principle does not only have to work with things that involve 2 operations, but it can work with anything that has 2 or more. For example, if we have another point over here labeled D, and say we had another 2 paths leading to it from C, then all we need to do is 4 times 2 times 2, because there are 2 paths from C to D, and calculate that. So the product principle can work with anything that has 2 or more operations. Now let's do an example. If we have this drawing where it shows all the paths from A to D, and we want to calculate the number of total paths we could take from A to D, first we will need to figure out, are these things successive and are they independent? Now, since A leads to B directly and B leads to C directly and C leads to D directly, we can all say that these paths are all successive and they are all independent just by judging from the picture. So now we need to find the number of paths in between each letter. So there's 3 from A to B, 3 from B to C, and 2 from C to D. And as we stated, we just multiply all these together, so 3 times 3 times 2, and we get 18 total paths, which is our answer. Now let's do another example. If we have these digits 2, 3, 4, 5, and 6, and we want to figure out how many 3-digit numbers can we make just using these 5 digits, then what we need to do is figure out are the operations we are doing successive and independent? And the operations in this case is putting the number into the hundreds, tens, or ones place. And yes, they are successive and they are independent. So first, let's do the hundreds place. And there are 5 possible digits we can use. So 5 possible numbers. And the tens place is the same thing. So 5, and the one place is the same thing, 5. And now we just multiply all these together, 5 times 5 times 5, and we get 125. This means that there are 125 numbers we can make that are 3 digits long and only use the digits 2, 3, 4, 5, and 6. Now, let's get into some practice problems. If we were given a license plate where the first 3 places should be letters and the remaining 3 places should be numbers, how many possible license plates could we possibly make? If you think you know how to solve that problem, then pause the video and try it. But the first thing we must do to solve this problem is just find out how many letters and numbers there are in total. So there are 26 letters in total and 10 numbers in total, 0 through 9. And so for each of the letter spaces, there are 26 possible possibilities. So 26, 26, and 26. And for the numbers, there are also 10 possibilities for each. So 10, 10, and 10. And each of these operations are successive and they are independent. So what we need to do is multiply all these together. 26 times 26 times 26 times 10 times 10 times 10. And in the end, our answer is 17,576,000. And you can figure that out just by plugging it into your calculator, but that's the answer. So if we have a license plate where the first 3 places are letters and the last 3 places are numbers, we can make 17,576,000 total license plates. Now, let's do another practice problem. If you think you know how to do this one, then pause the video and try it. But this problem asks, how many different ways can you rank 2 people from a bigger group of 7? And what this question means is that imagine you have a group of 7 people and you must choose 2 people and rank them above one another. So, which means that the ranks they have will be different. So the order matters in how you rank these two people. So let's draw two spaces or two lines representing the two ranks. And since we have a group of 7, there are 7 possibilities for the first rank. So let's draw a 7 right here. And for the second rank, you might think there are also 7 possibilities since there are 7 people in the group, but we've already chosen one person for the first rank. So this means that we have a total of 6 possibilities for the second rank. And now all we need to do is multiply these numbers together. 7 times 6 is equal to 42, which means that you can rank 2 people from a bigger group of 7 in 42 different ways. Now, let's do one last practice problem. If you think you know how to do this one, then pause the video and do it. This problem asks, how many ways can 4 letters be mailed in 3 mailboxes? Now, at first you might think we should just draw 3 lines representing each mailbox, and that seems like it works at first, but the 4 letters can go into any of the mailboxes, and what I mean by that is this mailbox, the first mailbox, can have letter 1, letter 2, letter 3, or 4, so we can have all 4 letters and the rest would have none. So this idea would not work. Instead, we should draw 4 lines representing each letter. So for the first letter, it can go into any of the 3 mailboxes, so let's write 3. And for the second letter, as we stated before, just because we put the first letter in one mailbox does not mean we have to put the second letter in a different mailbox. So this one is also 3. The third one is also 3, and the fourth one is also 3, using the same logic. So all we need to do now is multiply all these together. 3 times 3 times 3 times 3 is equal to 81. So there are 81 ways that you can mail 4 letters into 3 mailboxes. So everything that I explained and all the problems that I went through should teach you everything that you need to know about the product principle and how to use it. If you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.